Welcome everyone. In this video lecture, we will solve a GATE 2015 EC question in which we have to draw the graph between ID versus VSS curve in an NMOSFET. So the question is for a given NMOSFET circuit. Okay, this one is the circuit. The threshold voltage is VTH where VTH is greater than 0 and the source voltage is VSS is varied between 0 to VDD. So this voltage will be varied from 0 to VDD. Okay, so and we have to neglect the channel and modulation. So we have to find the drain current ID as a function of VSS. That is our ID versus VSS curve. We have to draw. Okay, so the thing is that this one is a question. Okay, and this one is the gate of the NMOS, and this one is the drain, and this one is the source. Okay, so now before this, what we have to do, we have to identify in which mode the NMOS is operating. So as we know, if the VDS value will be greater than equals to VGS minus VT, the NMOS will be in the saturation region. Saturation, the NMOS region, NMOS. Okay, and VDS is less than equals to VGS minus VT, so the NMOS is in the linear region. So we have to identify in which region the circuit is operating. So here the gate and drain are sorted. Okay. Here the gate and drain are sorted. Okay. So what we are writing VDS and I am writing VGS minus VT. Okay. Okay. So what we can write VD minus VS and here I am writing VG minus VS minus VT. So this should be cancelled out. Now we are just assuming that for the time being I am saying the device is in the saturation region. So this this drain voltage will be always greater than Vg minus Vt for saturation. Okay, and now Vd equals to Vg. This was a diode connected device. So Vg equals to the drain voltage is same as that of gate voltage. So this side will be always greater than this one. Okay, due to this Vd equals to Vg. Okay, this will be always greater. These two are common. So Vd and here Vg minus Vt. For example, if I am saying this value is say 5 volt. Okay, so this one is 5 and I am saying the Vt is 1 and Vt is 1. So this will be always greater. Okay, so the device is in the saturation region. So it is very important point that when gate and drain is sorted, device is in saturation. So now we have to write the drain current equation in the saturation region. So ID in saturation formula we know mu n W by L by 2 into VGS minus VT whole square. Okay, this one is the equation. So now what we can do here, I am writing only K for all these things mu n Cux W by L by 2. Okay, and Vg we can write Vg minus Vs minus Vt whole square. Okay, for all these things, we are writing K. Okay, some transconductance parameter. So now what we have to do, we can say this one is K. Vg is nothing but simply VDD because it is connected to supply. So Vg is simply VDD. Here also we can write this one is a VDD. So VDD minus this Vs. The source voltage is over here Vs. So make it Vs. Okay, minus Vt whole square. Okay, so this one is the expression. So ID is nothing but simply our k times of VDD minus VSS minus VT whole square. Now we have to plot. Okay, so here we observe that this one is our ID equals to some k x square, means a square one, a square law it will follow. Okay, so now what we have to do, this one, so we have to identify. So now from this picture we can observe that the when the VSS value will be, and here this VSS value will vary from VDD 0 to VDD. This VSS will vary from 0 to VDD. Okay, so what we can say, when ID equals to 0, okay, and this value is also VDD minus VTH, this point. Okay, so ID will be 0 when, if we put VDD minus VDD minus VTH minus. Okay, so for this value, when VSS equals to VDD minus VTH, the value will be 0, so it is 0 here. Okay, and when VS equals to 0, this will give the k times of VDD minus VT whole square. So it will give the maximum current, maximum current. So this one will be followed here. Okay, but one can also say in the option number D, this one is also following this one, but this, it cannot be this linear one because it is a parabolic one or a square law. It will follow a square law. So this will be the correct option for this question. Okay, and also if we are taking VSS equals to VTH, VSS equals to VTH, it is coming k VDD square. Okay, so k VDD square will be, the graph is like this. No, it will be not possible. Also when VSS is 0, ID will be not 0. Okay, so this one is also not possible. So as per the instruction, we can say the A, option number A will be the correct answer. This one is the correct graph for this one. Okay, this one is the correct answer for this circuit. Okay, it looks like this one is also follow the same one, but here it is a quadratic one, so we have to do, go for this one. For VDD minus V8, it should follow like this. So first we have to identify the saturation region when gate and drain is there. You can also identify using the this expression. Okay, so now we are writing the drain current equation. Then we have to plot the graph by just substituting the value where VDD minus VTH VS, it is coming ID 0, and when it is VSS is 0, ID is at peak. Okay, so that kind we can easily say that it is same here also, but it cannot be the linear, like linear expression. It should be a curve expression, curve. So x squared law it will follow, it will curve. So these two will be the wrong one. So option A will be the correct answer for this question. So you have to use the concept of simple saturation current expression, drain current equation in saturation region, and how at different point, at 2 points, what how it follows the curve, you can easily do. So this is an easy question, but we have to careful about the concept of simple MOS. Okay, so thank you for watching this video.